This is a quick lesson to introduce some ideas around naming cations and anions. We learned this week about how an ion is an atom that has either more protons than electrons or more electrons than protons. This document that you got in class today outlines some of the common ions. These are ones that we want you to know. A couple of things to notice. This table is organized so that all of the ions that you need to know that have a +1 charge are listed first, then +2 and +3. Notice that I'm not circling the blue ones yet. We'll get to those in a minute. So these are ones that we want you to both know what is the charge on this ion. So for example, here we see a 1+. We don't write the 1, we just write a plus, or a 2+. So we want you to know, for example, that hydrogen, its charge is 1+. There we go, 1+. And beryllium, its charge is 2+. And aluminum, its charge is 3+. The other thing we want you to know is we want you to know how to name these ions. So let's start with the naming. When we're talking about simple cations, a simple cation is just an atom that has lost one or more electrons. So here's the definition of a simple cation. Just for contrast, there are also things called complex or polyatomic cations. Oops. And there's an example down here. We don't need to know those just yet, but we will later in the semester. So the thing you'll notice about this list for simple cations is all of these are a single atom that in this case has lost one electron, which is why it's got one more proton than electron, or 2 electrons, which is what gives it a +2 charge, or 3 electrons. In each of these cases, the name of the cation, the hydrogen ion, the lithium ion, the sodium ion, the potassium ion, rubidium, cesium, etc., the name of a cation is exactly the same as the name of an atom. We will not be asking you to memorize all the names of elements in the periodic table, but I do want you to know these. So I want you to be familiar with these cation names, which really means becoming familiar with the atoms' names or the elements' names. The other thing I want you to know is I want you to be able to predict for each of these types of elements what the charge is. Now you could just memorize this list, but I'm going to give you a hint. And that is, if we look at the periodic table, what you will find is that all of the ions that have a +1 charge are in this very first column of the periodic table. So if I asked you, what about potassium? What kind of ion does it form? You would say, everything in this column appears to lose 1 electron, so that must mean that its charge is +1. Later, as the semester goes on, we'll learn kind of why do things in this group of the periodic table, why do they all lose 1 and not more than that, for example? But we'll get there. Likewise, if we look up here at the +2 ions, they are all in this column here. So they tend to lose 2 electrons, and that leaves them with a charge of +2. So if I asked you, what's the charge on calcium when it becomes an ion, you would say, oh, it's in that column, it must be a +2. Now aluminum is over here by itself. Remember that aluminum has a +3 charge. And that one, probably the best thing to do is to just, for now, just memorize that it has a +3 charge. Now, one thing to recognize about the periodic table is that everything that is on this periodic table, green, yellow, and these peachy and orange colors over here, they are all metals. Technically, hydrogen is not a metal, but we're going to group it in with them for now. And metals tend to lose electrons. And when they do, they become cations. These blue and purple ones over here are nonmetals. Technically, the light blue ones are called semimetals or metalloids, and they can do both, lose and gain electrons. But the purple and the blue over here are nonmetals, and nonmetals tend to gain electrons. All right, so now let's turn our attention to all of these ions that are listed in blue. If you look carefully, all of these ions, copper, gold, silver, copper, and you can see there's some Roman numerals, we'll get to those in a minute, chromium, cobalt, iron, lead, manganese, all of these come from this part of the periodic table, which is the transition metal section of the periodic table. And unlike the other sections of the periodic table, where, for example, you could look and say, oh, anything in this group is going to be a +1 ion, and anything in this group is going to be a +2 ion. It turns out the transition metals can form different kinds of ions. So, for example, here is iron with a +2 charge. It means iron has lost 2 electrons. But here's iron with a +3 charge, which means it's lost 3 electrons. And because something like iron or copper or cobalt or manganese has the ability to lose, maybe it's 2, maybe it's 3, maybe it's 4, maybe it's 7 electrons, when we name it, we have to explain how many electrons have been lost. And the way we do that is, for example, let's use iron 3+ here. When I name iron 3+, the way that I communicate that iron 3+ has lost 3 electrons is I call it iron 3. So in other words, I put the Roman numerals, put the 3 in Roman numerals. So the 3 tells me what the charge is, and then that also tells me how many electrons has been lost. And that allows me to contrast that iron with this iron, which we call iron 2, to indicate that it has lost 2 electrons. Anytime you are naming a transition metal ion, you have to specify the Roman numeral. You have to include the Roman numeral in there. Oh, I don't know why silver's missing here. That's a typo. But the ions here, the name is the same as the name of the atom. So for example, here if we take Cu, the neutral atom is called copper, and the ion is also called copper, but we have to put the 2 in Roman numerals to specify that this is copper 2+, which is different than copper 1, which is copper 1+. For now, we're going to focus on the simple anions. And just as was the case with simple cations, a simple anion is just an atom that has gained some extra electrons, 1 or more. As before, there's something called complex ions or polyatomic ions. You are going to need to be expected to know these, but not yet. Let's go back to simple anions. So these are the ones we want you to know. And notice that these again are organized. These are the ones that are 1-, which means these are atoms that have gained a single extra electron. These are 2-, these are atoms that have gained 2 extra electrons. And 3- have gained 3 extra electrons. In order to know how to name these, the rule about naming anions is you take the atom's name and you change the suffix to IDE. So for example, fluoride comes from the atom's name fluorine. After it gains an electron, we call it fluoride. Chloride comes from chlorine, but once it gains an electron, we call it chloride. Same thing with bromide and iodide. Oxide comes from the atom oxygen. We drop all the stuff at the end and we just call it oxide when it has those 2 extra electrons. Sulfide comes from sulfur, but we call it sulfide when it has a negative charge. Nitride comes from nitrogen, and phosphide comes from phosphorus. So the pattern is that if you know the atom's name and it becomes an anion, you just change the suffix to IDE. Likewise, if you see the suffix IDE, then you know you've got an ion. Now, how are you going to learn these charges? You could just memorize this table, or we could go look at the periodic table. Notice that these fluoride, chloride, bromide, and iodide all come from atoms that are in what's called group 7A. Those are called the halogens. And so everything in this group will tend to gain one electron and become a simple anion like fluoride, chloride, bromide, or diide. Likewise, if we look at the 2- charged ions, they are in group 6A. So things in this group tend to gain 2 electrons. So even though the ion of selenium is not on this list, you might be able to guess that selenium probably gains 2 electrons, and we would call it selenide. Finally, nitride and phosphide come from elements that are in group 5A. So these elements tend to gain 3 electrons, and when they do, we call it nitride or phosphide. So based on where things are in the periodic table, if I said, what kind of ion does sulfur form, you should be able to say, oh, okay, these are 1-, these are 2-, these are 3-. So sulfur must be 2-. This concludes the introduction to simple cations and anions. You are now ready to take the quiz.